Bismillah Rahman Rahim. I am Sarah Khan, your instructor for the course titled Application of Statistics in Psychology with course code 509. This is our 23rd lecture, which is very much connected to the previous lecture. We were discussing ANOVA, hypothesis testing with ANOVA. In this lecture, now we will discuss ANOVA notations and the formula, and all the formulas for the computation of mean, standard deviation, variance, and the sum of square of deviations, because ANOVA typically is used to examine the data from the more than two treatments conditions. So there are more than two samples involved in the ANOVA typically. So we need some notational system to keep track for all the individual scores and the totals. To help to introduce this notational system, we will see how and with which respect we give these notations to the different means of the different populations, different variances of the different samples. First, we will take the quick review of our previous lecture. Then we will learn all the notations and the formulas which are used in ANOVA for the hypothesis testing and using in the calculation of the F ratio of the F test. So, with the quick review, the purpose of the ANOVA is much the same as the t-test presented. The goal is to determine whether the mean differences that are obtained for the sample data are sufficiently large to justify a conclusion that there are mean differences between the populations from which the samples have been drawn. Analysis of variance is a hypothesis testing procedure actually that used to evaluate mean differences between more than two treatments or treatments and the populations or the samples. As with all inferential procedures, ANOVA uses sample data as the basis of drawing general conclusion about the population. This can be clear from this picture. In this figure, there are three populations, and we have drawn three different samples from these three populations. And this typical research situation for which the ANOVA would be used. For this research study involves three samples representing three populations. The goal of the analysis is to determine whether the mean differences observed among these samples provide enough evidence to conclude that there are mean differences among the three populations. In the first step is to determine the total variability of the entire set of the data. Once we have measured the total variability, we can begin to break up this total variability into separate components. The word analysis actually means dividing into smaller parts because we are going to analyze variability. The process is called analysis of variance. This analysis process divides the total variability into two basic components. Analyzing the total variability into two components is the heart of the ANOVA. I remember that calculating the variability or the variance is simply a method of measuring how big the differences are for the set of number. When we see the term variance, we can automatically translate it into the term of differences. Once we have analyzed the total variability and its two components between treatment and the within treatment, we simply compare them. This comparison is made by computing an F ratio. This is an F ratio for independent measure ANOVA. The F ratio is the variance between treatment divided by variance within treatment, or this can also be equal to differences including any treatment effect and differences with no treatment effect. The value of F ratio help to determine whether any treatment effect exists or not. When there is no systematic treatment effect, the difference between the treatment nominator are entirely caused by the random and unsystematic differences. In this case, the numerator and the denominator both of the F ratio are both measuring the random differences and should be roughly have the same size. Thus, an F ratio which having the same size or nearly equal to 1 indicates that differences between the treatments are random and unsystematic, and just like the differences in the denominator. And when the treatment has an impact causing systematic differences between the samples, then combination of the systematic and the random differences in the nominator should be larger than the random differences alone in the denominator. In this case, the nominator of the F ratio should be noticeably larger than the denominator, and we can conclude that treatment has there is some differences in the treatments, and the treatment has an effect. Next is the degree of freedom. The concept of the degree of the freedom. The degree of freedom is the vote needed to calculate the critical region for the hypothesis testing. To see the tabulated value of the F ratio from the table, we need the DF of between treatments and the D of the within treatments. We also use this DF for the calculation of variances. We first calculate the sum of square of deviations, then from SS by using the SS and dividing it with the number, we will calculate the variance between the treatment and the variance within the treatment. So as like the variability has been divided into two basic components, between treatment variance and the within treatment variance. Just like that, DF is also divided into two components: DF of between treatment and DF within treatment. DF to calculate the calculation of or finding the analysis of the degree of freedom follows the same pattern as the analysis of SS. First we find the DF for the total and scores, and then partition this value into two components: degree of freedom between treatment and the degree of freedom within treatments. In computing degree of freedom, there are two important considerations to keep in mind. First, this in mind, we will examine the degree of freedom for each part of the analysis. Total degree of freedom, to find the DF associated with SS total, we must recall that in SS value measures the availability for the entire set of n scores. Therefore, the DF total will be n minus 1. And within treatment, to find this within DF within treatment also associated with the computation of the SS values. Remember that we find the SS inside of each of the treatment and then add these values together. Each of the treatment SS value measures the variability of n scores in the treatment. So each SS has DF n minus 1. When all these individual treatment values have added together, we obtain DF summation n minus 1 is equal to n minus k. And for the DF between the treatments, there are three groups or the three levels of the IV, which is denoted by the K. We calculate or compute the variability or the SS with respect to the SS formula measures the variability for the set of the treatment. To find DF between, simply we will count the treatment number of the treatments and subtract 1 from that, because the number of the treatment is specified by the letter of K. The formula for DF is between treatment K minus 1. इस टेबल को अगर हम देखते हैं तो हमारे पास 3 सैंपल हैं और उसका टोटल T1, T2, T3 से डिनोट किया गया है. इसी तरह से हर किसी का जो SS है, सम ऑफ स्क्वायर डेविएशन जो मालूम किया है, उसके साथ 1, 2 और 3 लिखा है. इसी तरह से उनकी जो N है उसके साथ भी 1, 2 और 3 लिखा गया है. और इसी तरह से उनकी जो मीन है उनके साथ भी इसी तरह से लिखा गया. इसमें से जो एक टर्म नई है वो T है, और इधर से एक G जो टर्म है ये भी एक नई है, और एक ये K जो टर्म है ये भी एक नई टर्म है. हम इस एग्जाम्पल को फोकस में रख के सब ये जो नोटेशनल सिस्टम है इसको समझने की कोशिश करेंगे, और फिर इसी सिस्टम को मद्देनज़र रखते हुए हम सारी कैलकुलेशंस करेंगे ANOVA से मुताल्लिक़. To help introduce this notational system, we use the hypothetical data from the table. This table is 12.2, along with some of the notations and statistics that will be described. First of all, the letter K is used to identify the number of the treatment conditions for the data in the table. There are 3 treatments, so K is equal to 3. So the letter K is used to identify the number of the treatment conditions. That is, we can also say that the number of the levels of the factor, or the number of the levels of the independent variable. For an independent measure study, K also specifies the number of the separate sample. For the data in the table, previous table, table 12.2, there are 3 treatments, so the K is equal to 3. Second, the number of the scores in each treatment is identified by a lowercase letter n. For example, N2 is the number of the scores in the treatment 2, so N2 is equal to 5. यानी इस जो हमारे पास टेबल है, इसमें देखिए कि हम n स्मॉल n के साथ ये लोअर केस में अगर पहला सैंपल है तो उसके साथ 1 लिख देंगे, अगर दूसरा सैंपल है तो उसके साथ 2 लिख देंगे, और अगर तीसरा सैंपल है तो उसके साथ 3 लिख दिया जाएगा. तो इस तरह से जो नंबर ऑफ स्कोर्स इन ईच ट्रीटमेंट, हर ट्रीटमेंट का अलग अलग जो नंबर है उसको हम लेटर n से डिनोट करते हैं, और लोअर केस में ये स्मॉल n से डिनोट करते हैं, और हर जो ट्रीटमेंट का लेवल है और जो उसके साथ जो नंबर ऑफ पार्टिसिपेंट्स हैं उसको कैलकुलेट करके उसके साथ हम लिख देते हैं. जैसे कि अगर हम ट्रीटमेंट 2 को देखें तो उसमें 5 पार्टिसिपेंट्स हैं, हमने n स्मॉल के साथ 2 सैम्पल 2 है चूँकि, तो 2 लिखा और वो इक्वल है 5 के. इसी तरह से द टोटल नंबर ऑफ द स्कोर्स इन द एंटायर स्टडी इज स्पेसिफाइड बाय कैपिटल लेटर n. When all the samples are the same size, then n is constant. Then n, capital N, or the entire scores in the entire study equal to K. K is the number of the treatments, and into n. जैसा कि K हमारे पास की वैल्यू 3 है और n की वैल्यू 5 है, तो हमारे पास n जो है वो 15 के बराबर आ जाएगा. लेकिन अगर सैम्पल, कुछ सिचुएशंस ऐसी भी होती हैं जहाँ पर सैम्पल साइज़ इक्वल नहीं होता, जहाँ पर सैम्पल साइज़ इक्वल नहीं होता वहाँ हम इस फार्मूले को यूज़ करके n कैलकुलेट नहीं कर सकते. उसके लिए फिर हमें तीनों जो ट्रीटमेंट्स हैं, ये 4 ट्रीटमेंट्स हैं, या IV की 4 लेवल्स हैं, तो उन सबको प्लस करके फिर हमें लिखना पड़ेगा कि n कितना बना है. और इसी तरह से द सम ऑफ द स्कोर्स, जिसे हम समेशन x कहते थे, यहाँ ऑफ ईच ट्रीटमेंट कंडीशन विल बी आइडेंटिफाइड बाय द कैपिटल लेटर T. The total of the specific treatment can be identified by adding the numerical subscript to the T. So T is the capital letter and 2 is the subscript, will be equal to is equal to 5. इसको आप प्लस कर लें, 3, 4 and 5, and T2 is equal to 5 and T1 is equal to 20. इसको सबको प्लस करेंगे तो हमारे पास 20 आ जाएगा, और इसी को सबको प्लस करेंगे तो हमारे पास 5 आ जाएगा, and T3 will be equal to 5. और इसी तरह से नेक्स्ट है द सम ऑफ ऑल स्कोर्स इन द रिसर्च स्टडी, द ग्रैंड टोटल is identified by G. You can compute G by adding up all the n scores or by adding up the treatment totals. G is equal to summation T, or the G is equal to T1, T2 and T3, इन सबको हम अगर प्लस कर लेंगे तो हमारे पास ग्रैंड टोटल आ जाएगा, which is denoted by G. We have to calculate summation x square for the entire set of data, that is n, 15 schools in the study. So the summation x square is equal to 106. Practically we will do all these calculations. So we will calculate, first we will calculate M1, which is the mean score of sample 1 or the treatment 1. T1 is equal to 20 and N1 is equal to 5. Which is equal to 4. When we divide 20 and then by 5, it will be equal to 4. And the mean score of M2 is the mean score of group or the sample 2, second sample. Sorry, this is the second sample. This is the squared values of the sample 1. Okay, T2 is equal to 5 and N is also 5. Then the mean value of sample 2 is equal to 1. T3 is also 1 and N3 is also 5 and the mean value is also 1. SS को कंट्रोल करने के कैलकुलेट करने के लिए SS which is the sum of square deviations को कैलकुलेट करने के लिए, क्योंकि हमें ये SS की कैलकुलेशन वेरिएंस को कैलकुलेट करने के लिए ज़रूरी है. तो पहले ग्रुप का SS कैलकुलेट करने के लिए विच इज़ SS1 हमें चाहिए इसका समीशन x1 स्क्वायर का और देन हमें वैल्यू चाहिए T1 की जो कि और उसका स्क्वायर हमें लेना है और उसे N1 से डिवाइड करना है. तो हमारे पास जो वैल्यू है वो है 86. x1 हमने किया क्या है, इसका स्क्वायर लिया 16 आ गया, इसका स्क्वायर लिया 9 आ गया, इसका स्क्वायर लिया 36 आ गया और इसका स्क्वायर लिया 9 आ गया और इसका स्क्वायर लिया तो 16 आ गया. इन सबको प्लस किया तो हमारे पास 86 आ गया. तो SS1 को कैलकुलेट करने के लिए हमारा फार्मूला है समीशन x स्क्वायर, समीशन नहीं डाला, समीशन में डाल देती हूँ. These are the symbols. This is the summation. So the summation x1 square is 86 and we have to calculate T1 where we will write 20 and divided it by 5. Okay, 86 minus 400 divided by 5 and 86 minus 80. When we divide 400 by 5, we will get 80, and 6 is the SS1. In the same way, we will calculate calculate SS2, means the sum of squared deviation for group 2 or the sample 2. We will take the square of each value. 0 का स्क्वायर ऑब्वियसली 0 ही होगा, 1 का भी 1 ही होगा, 3 का 9 एंड 1 का 1, और इन सबको जब हम प्लस करेंगे तो वो हमारे पास आ जाता है 11. So we will put the value 11 in the place of summation x2 square, and t2 is equal to 5, and we will divide it by 5. So 11 minus 5. When we open the 5, the square, when we open the square of 5, which will be equal to 25, and we will divide 25 by 5, which will be equal to 11 minus 5 and equal to 6. We also calculate the SS for group 3 or the sample 3, and we'll use the summation sign here, and summation x3 square is equal to 9, and t3 is also 5, and divided by 5, which is equal to 9 minus 25 by 5, and 9 minus 5 is equal to 4. Okay, SS1 6, SS2 6, and SS3 is 4. Now we will recheck it from SS6, SS2 6, and SS3 is 9. In this way, we will calculate the sum of square deviation for each group. This SS1, SS2, and SS3 will be used when we will compute the value of variance within treatment.